So if we continue with the problem, take note that it is important to make sure that all of the units in each of the quantities here should be in MKS, otherwise known as meter, kilogram, and second. The reason here is if it is not in MKS and you're going to make use of the suvat equations, which I'm going to explain later on, it will be inconsistent and you'll end up with a wrong answer. So you check the quantities. So time is in second, it's okay. You have the well, most likely the H1 and the H2, they'll be in meters. Velocity will be in meter per second, and acceleration will be meters per second squared. Now the suvat equations are as follows. First, we have the definition of average velocity, which is simply the final velocity plus the initial velocity, and this is divided by 2. This can be equated to that of the displacement per unit time. The second one is the definition of acceleration, which is just the final velocity minus the initial velocity, otherwise known as the change in velocity per unit time. The third suvat equation is the combination of equations 1 and 2, but finding out the displacement. If you're going to combine these two equations, you'll end up with the displacement is equal to the initial velocity times time plus 1/2 the acceleration time squared. The fourth suvat equation, or equations, one among the equations of motion, is the final velocity squared is equal to the square of the initial velocity plus twice that of acceleration times that of the displacement. Now, knowing all the suvat equations and knowing the diagram, we can now proceed to solving problem A.